in the vast ocean of stars, hidden within the constellation of Cetus, lies a world that could be our cosmic twin. Just 16 light-years away practically in our cosmic backyard, astronomers have found a planet that looks eerily familiar. They call it GJ1002b, a rocky world almost the same size as Earth, orbiting a tiny red sun. Could this be one of the closest places in the universe where life might exist? In the vastness of space, where distances are measured in lifetimes, a journey of 16 light-years is like a trip to the next town over. This is the home of GJ1002b, a planet that has captured the imagination of astronomers worldwide. The discovery of this world wasn't made with a snapshot from a powerful space telescope. Instead, it was revealed through a delicate cosmic dance. Scientists detected it by observing the subtle wobble of its parent star, a gravitational tug-of-war between the star and its unseen companion. This intricate measurement was performed by two of the most sensitive instruments on Earth, the Espresso spectrograph in Chile and the Carmen's spectrograph in Spain. The star at the center of this system, GJ1002, is what's known as a red dwarf. It belongs to the spectral type M55V, which means it's small, cool, and incredibly dim compared to our own sun. Its light is a faint reddish glow, barely visible to the naked eye from Earth. For a long time, we thought stars like this were poor candidates for hosting life. But around this faint cosmic ember, we've found not just one, but two planets, and one of them, GJ1002b, has sent a ripple of excitement through the scientific community. It orbits in a region that might hold the answer to one of humanity's oldest and most profound questions. Are we alone? Let's take a closer look at this fascinating world. What makes GJ1002b so special? For starters, its size. With an estimated mass just 1.08 times that of Earth, it's practically our planet's twin in terms of size and likely gravity. Imagine standing on its surface. The pull you'd feel would be almost identical to what you feel right now. But that's where the similarities start to get weird. GJ1002b is locked in a blisteringly fast orbit, completing a full year in just 10 Earth days. It hugs its star at a distance far closer than Mercury is to our sun. Now, you might think that being so close would make it a scorched, barren rock. But remember, its star is a cool red dwarf. Because the star is so dim, GJ1002b actually falls squarely within its habitable zone. This is the Goldilocks region, where the temperature is just right for liquid water to exist on a planet's surface. Not too hot, not too cold. Scientists use a metric called the Earth Similarity Index, or ESE, to rate how Earth-like an exoplanet is on a scale from 0 to 1, with Earth being a perfect one. GJ1002b scores an astonishing 0.86. This is one of the highest ESI values ever found for an putting it in an elite club of worlds that could just maybe feel a little like home. So let's use our imagination. What would it be like to stand on the surface of GJ1002b? The sky above wouldn't be a brilliant blue, but a permanent, deep reddish twilight. The sun in that sky wouldn't be a blinding golden orb. Instead, it would appear as a large, dull ember, glowing faintly, perhaps diffused by a thick, hazy atmosphere. There's a good chance that GJ1002b is tidally locked to its star. Just as our moon is to Earth, this means one side of the planet would permanently face the star, bathed in constant, dim daylight, while the other side would be trapped in an eternal, frozen night. This creates three distinct zones. The day side, while perpetually lit, might have temperatures mild enough for liquid water to flow in rivers and pool into lakes. The night side would be a wasteland of perpetual ice and darkness, unimaginably cold. But the most interesting part lies in between a narrow terminator zone or twilight zone that separates the two extremes. In this perpetual dawn or dusk, the conditions might be just perfect. The temperatures could be stable, the light gentle, and it is airy in this sliver of temperate land that astrobiologists believe life would have its best shot. But could life really survive in such an environment? Red dwarf stars have a notorious reputation. They are known for being temperamental, often unleashing violent solar flares that could blast nearby planets with lethal radiation and strip away their atmospheres. These flares would sterilize a planet's surface, making life impossible. However, the star GJ1002 appears to be unusually quiet for a red dwarf. Its relative calm is a crucial piece of the puzzle. This stability greatly increases the chances that its planet, GJ1002b, could have held on to a thick atmosphere over billions of years. An atmosphere is key. It would act as a protective shield against cosmic rays and any occasional flares, and it would trap heat, preventing the planet from freezing over. This atmosphere could regulate temperatures across the surface, maybe even allowing for oceans or vast lakes to exist beneath a hazy orange sky. Astrobiologists speculate that if life did arise here, it would likely be simple microbial life, perhaps thriving in the twilight regions. It wouldn't rely on the same bright yellow light that powers photosynthesis on Earth. Instead, it would adapt to the star's infrared UV spectrum, evolving unique ways to harness energy from the dim red glow. If this is true, GJ1002b might not just be, it could be alive. So, how can we find out for sure? For now, GJ1002b is just a series of data points a wobble in a star's light. But that's about to change, because this planet is so close to us, it's a prime target for our most advanced telescopes. The James Webb Space Telescope, with its incredible sensitivity, is expected to turn its gaze towards this system. Further down the line, massive ground-based observatories like the Extremely Large Telescope, or ELT, will have the power to analyze the light that passes through the planet's atmosphere. By studying this light, we can look for biosignatures, the chemical fingerprints of life. We could detect the presence of gases like carbon dioxide, methane, or even oxygen. Finding these in the right combination would be a monumental discovery. It would be like hearing the first breath of another world. GJ1002b could become one of the first Earth-sized exoplanets where we can truly analyze the composition of the air, searching for signs that something is living and breathing just 16 light-years away. Just stop and think about that for a moment. A journey that would take our fastest spacecraft hundreds of thousands of years is, in the grand cosmic scheme, just next door. Out there, orbiting a faint red star, is a world that could have continents, oceans, and winds. A world where, just maybe, something is looking back towards its own dim, red sun, wondering if it's alone. Every discovery, like GJ1002b, brings us one step closer to answering that fundamental question. It helps us understand whether Earth is a unique, precious jewel in the cosmos, or just one of many vibrant, living worlds scattered throughout the galaxy. The discovery of GJ1002b isn't just about finding another planet, it's about finding our place in the universe. The abyss of space is vast and silent, yet it whispers of worlds like GJ1002b, reflections of ourselves in the dark. These discoveries are more than just science. They are a source of wonder, a testament to our relentless curiosity. Perhaps one day we'll cross that abyss and our distant descendants will stand beneath that red sky. Until then, we gaze upward, we continue to search, and we wander. Thanks for joining us on this journey into the unknown. If you want to explore more cosmic mysteries, be sure to subscribe.